Welcome to CSE Guru. In this session, we will discuss Introduction to Stack in Data Structure. Stack is a fundamental data structure in computer science. This is a very important data structure we will use most of the applications in programming. And stack stores its elements in an ordered manner. In specific order only, it will store the elements. Either it may be an insertion or deletion will happen in specific order only, it will store the elements. The first element will be placed at the bottom of the stack. Next element will be placed at the top of the first element. And then the next element will be placed at the top of the second element and so on. For example, if you are considering the stack data structure in the sense, the first element, if I'm pushing A in the sense, the first element will be pushed into the stack. And this will point as the top of the stack. And when I'm pushing the second element B, it will be placed on the top of the first element. The first element will be at the bottom. Okay. The second element will be placed at the top of the first element. Now the top will point here. Okay. When you are pushing the next element C, it will be placed on the top of the second element. When you are pushing the fourth element, it will be placed on the top of the third element. Likewise, the procedure continues. Always, top of the stack will point to the last element what you have pushed. This represents the top after insertion of element D. So here, if you are considering in the sense, insertion will happen at the top of the stack. And suppose if you want to delete an element in the sense, the first element to be deleted here is D. Because the only element we can able to access from the top of the stack is D only. All the remaining elements will be at the bottom. We cannot able to access it. Okay. So the first element we can able to delete here is D only. So deletion also will happen at the top of the stack only. So both insertion and deletion will happen at the top of the stack. And after deleting the element D, now the top will point to C. Top element will point to C, not D. Okay, D is deleted. Okay, and after deleting C, now top will point to B. And after deleting B only, you can able to delete A. Okay, so in this order only, in ordered manner only, you can able to insert, as well as in ordered manner only, you can able to delete. Okay, so pushing in the sense, first element will be at the bottom. Next element will be placed on the top of the first element. Next element will be placed on the top of the second element. Next element will be placed on the top of the third element. Likewise, the procedure continues in ordered manner. This is insertion. And when you are deleting in the sense, the last element what you have pushed into the stack, that is D here. Okay. The last element what you have pushed into the stack, that element will be deleted first. After deleting D only, you can able to delete C. After deleting C only, you can able to delete B. After deleting B only, you can able to delete A. In this order only, the deletion will happen. So, insertion and deletion will happen in an ordered manner. Okay, and both insertion and deletion will happen at the top of the stack. What is the top element it is pointing? Insertion in the sense, insert and top will be replaced by the new element what you have inserted. And deletion in the sense, delete the top element, next the top will point to the next element in the stack. So this is nothing but the stack data structure. So best example for stack data structure is pile of plates. So when you are placing a plate in the sense, the first plate here in the sense, the next plate will be placed on the top of the first plate. And next plate will be placed on the top of the second plate. And next plate will be placed on the top of the third plate. Likewise only the procedure continues. And when you want to remove it, you can able to remove the fourth plate first, then the third plate, then the second plate, then the first. Okay, so this is the best example, pile of plates. Similarly, the bread and biscuits arranged in a pack. The first bread or the biscuit will be placed at the bottom of the packet, right? And the next will be placed on the top of the first. And next will be placed on the top of the second. Likewise only we can able to arrange either the bread packet or biscuit packet. This is the next best example. And the pack of cards, if you are considering in this sense, one card will be placed on the top of the another card, right? All the cards will be arranged in order only. That is, one card will be placed on the top of the other card. So these are all the best examples for stack data structure. Next, definition for stack. Stack is a linear data structure. What do you mean by linear? Elements will be arranged in specific order. That is linear. That is, the elements will be in sequential order. That is, next to next memory location, elements will be arranged. Okay, so elements will be arranged in any specific order in the sense that is called linear data structure. For example, sequential data structure. Stack is a sequential data structure. Queue is a sequential data structure. That is, the elements will be stored next to each other, and which uses the same principle. That is, elements are added and removed only from one end of the stack. Okay, that is, the stack, if you are considering in the sense, addition and deletion will happen only at the one end, right? Not at the bottom. Bottom we won't consider at all. Okay, only the top only we will consider. Elements will be pushed at the top, will be deleted at the top only. That is stack data structure. Stack is a linear data structure which uses the same principle. Elements are added and removed only from one end of the stack called the top. And here, stack is called a LIFO data structure. Last in, first out data structure. That is, what is the element you have pushed into the stack at last, that will be removed first. For example, A, B, C. First you are pushing A, second element is B, third element you have pushed here is C. Now the top will point to C. And when you want to delete it in the sense, the last element what you have pushed into the stack, that is C, that will be removed from the stack first. That is last in, first out. So stack is a last in, first out data structure. After deleting element C, now top will point to B, the next element. Okay. So last element what you have pushed into the stack, that will be removed from the stack first. So example here, this is the arrangement of plates. Okay, that is a pile of plates. This is the first plate, second plate, third plate and fourth plate. So another plate will be added on the top of this plate. This is the fourth plate. Fifth plate, if you want to insert in the sense, the top of the fourth plate only you can able to insert the fifth plate, right? And the topmost plate only will be removed first. So if it is fourth plate in the sense, it will be removed first. If it is fifth you have inserted, it will be removed first. Okay. So insertion will happen at the top of the stack and the topmost element only will be removed from the stack first. That is stack data structure. Stack is a LIFO data structure, last in, first out data structure. And example for stack, if we are considering in the sense, where actually we are using the stack concept in computer application in the sense, best example is function call. So function A calls another function B, function B calls in turn another function C, and function C calls another function D. Okay, for example, so this is function A in the sense. Okay, function A is called. This is function A. This is the start of function A and this is the end of function A. And in turn here it calls function B. This is the start of function B. This is the end of function B. In turns it will call another function C. This is the start of function C. This is the end of function C. Here in turns it calls another function D. This is the start and this is the end. In between, whatever the statements you want, you can enter. Okay, here I have shown only the function call. So the function A is called first. Okay, so when the function A is called in the sense, the function A will be pushed into the stack first. This is function A. So once it is called, it will be pushed into the data structure first. Okay, and then it enters into the start of the function, then it will check the function B. Now function B is called. Push it into the stack. This is the start of function B. Then it checks function C. Now function C is called. Push function C into the stack. Next in turn, it calls function D. Okay. So in this order only, functions will be pushed into the stack once it is called. Okay. Now function A, when you can able to remove, function D should be removed first. Next function C should be removed and then function B should be removed. Then only you can able to remove function A. That is the meaning of function A, when it will complete its execution in the sense, function D should complete its execution, then function C, then function B. If all these three functions completed its execution, then function A will complete its execution and it will exit. Till that time, this function A is alive. Okay. So here, whenever the function is called, it will be immediately pushed into the stack. So here, first function D should complete its execution. Once the function D completed its execution. This all the statements it has to execute in between this start and end of the function. Okay. So once all the statements has executed and its purpose is over in the sense, it has completed its execution. That is the meaning. Next control will be transferred to function C. Now, function C, it has to execute all its execution. Whatever the remaining statements it is here, it has to execute all its execution. Then this function C completed its execution, control will be transferred to function B. Next, function B will have to complete all its execution. Then only it will transfer control to function A. And then only function A, apart from this function B, whatever the remaining statements it is there, it will execute it. Once it completes its execution, it will exit. The function will exit. Control will be transferred to the main function. Okay, once function A completes its execution, control will be transferred to main function. Okay, so this is the best example how stack data structure is used in computer applications, in programming. The best example is function call. Next, applications of stack. There are many different applications where we can able to implement stack data structure. Efficiently we can able to implement. The few applications are here. One is reversing a list. The list may be a number or it may be an alphabet or any string. If you want to reverse it in the sense, okay, reversed order if you want to present it in the sense, you can use stack data structure. Then parenthesis checker, that is how many open parentheses is there, that many closed parentheses should be there in programming. Okay, so here whenever you are implementing in large programs, that time this parenthesis sometimes the programmer may miss. They may open the parenthesis but they may forget to close it. Okay, so how many open parentheses they have used, correspondingly wherever it is required it should be closed. Wherever the application is completed it should be closed, but sometimes they may forget. Okay, this can be efficiently checked by stack data structure. This parenthesis also, this curly brackets also, it is there. How many open curly brackets should be there, that many closed curly brackets should be there. So for parenthesis checker we can able to implement stack data structure. And then there are three types of expressions it is there: infix expression, prefix and postfix expression. Okay, so these three are the common types of expressions we will use. What I mean by infix expression in the sense, the operator will present in between the operand. A and B are operands, plus is the operator. Operator will present in between the operands in the sense, that is called infix expression. That is a normal expression actually. And what I mean by prefix expression in the sense, operator will be preceded and then only we can able to place the operands. That is, operator should be placed first, then comes the operands. So plus is the operator, A is the first operand, B is the second operand. And postfix expression is nothing but operand should be placed first and then comes the operator. Okay, first two operands, next is the operator. So these are all the different types of expressions we will use. Okay, so here the applications of these three expressions if you are considering in the sense, conversion of infix expression into postfix expression. Infix expression they have given as an input. Output we have to get the postfix expression. For this purpose we can able to implement stack data structure. Then evaluation of postfix expression. So evaluation is nothing but, for example, A value I am giving as 5 and B value I am giving as 4 in the sense. I want to evaluate in the postfix expression. It should be in the postfix expression, that is AB plus. Okay, this is the postfix expression and value of A is 5, value of B is 4, both should be added. So if you are implementing this expression in the sense, this should be evaluated and we should get the result. For this implementation also we will use stack data structure. Similarly, conversion of infix to prefix expression. Infix will be given, should convert it into prefix expression. Okay, for that also stack data structure we will use. Evaluation of prefix expression, that is plus AB we will give it, that is plus A value is 5, B value is 4 if you are giving in the sense, this should be evaluated and it should produce the result. In this purpose also we will use stack data structure. Next comes the important application and important topic in stack and in programming is recursion. Recursion is nothing but a function calls by itself. For example, if add is the function, if it is there in the sense, Within this function itself, again the same function is called. That is called recursion. To implement this recursion concept also, we will use stack data structure. And one of the main application of recursion concept is Tower of Hanoi problem. So what do you mean by Tower of Hanoi problem? In the sense, there are three poles will be there. This is pole A, this is pole B, and this is pole C. There are three poles are there, and here three disks are there. This is the first disk, and this is the second disk smaller than the first one, and this is the third disk smaller than the second one. Okay, so three disks will be arranged in order such that largest disk will be at the bottom and next to smallest will be placed on the top. Okay, so now three disks is placed in the first pole. The problem is you have to move all the disks from pole A to pole C in the same order it should be placed. That is, the first disk at the bottom, second disk on the top of first disk, the third disk on the top of second disk. Likewise only in the same order only you have to place in third pole using B as intermediary. This is the problem. And what is the condition here in the sense? The smallest disk should be placed on the largest disk. You should not place largest disk on the smallest disk. That is the condition. Throughout solving the problem, you should not place largest disk on the top of smallest one. Always largest disk should be at the bottom. That is the first condition. And at a time, you have to move only one disk. That is the second condition. Okay. So with this condition, you have to solve this problem. To solve this problem also, we will implement stack data structure. Okay. So these are all the different applications of stack data structure. All these applications we will discuss in detail with examples. So this is all about introduction to stack. In the next session, we will discuss representations of stack. How stack will be represented in memory. That will be discussed. Okay. Thank you for watching this video.